In this video, we would like to introduce our joint booth and highlight three of the various demonstrators: Safety over EtherCAT, Master Independent Diagnosis Interface, and EtherCAT and TSN. This time, 56 co-exhibitors are presenting more than 500 different EtherCAT products and solutions. For easy navigation on the booth, the products are grouped in several categories: EtherCAT control systems, drive technology, I/O systems and gateways, sensors and actuators, safety over EtherCAT, as well as EtherCAT P. For all those who want to implement EtherCAT into own devices, a comprehensive collection of EtherCAT development hardware and software is available too. EtherCAT slave controller chips, evaluation kits, communication modules, but also software stacks are on display. Safety over EtherCAT defines a safety communication layer for the transportation of safety process data between safety over EtherCAT devices having safe and standard communication one channel. Safety applications make full use of EtherCAT performance advantages. The demonstrations shows the interaction of safety over EtherCAT devices from different vendors. Furthermore, two safe PLCs are exchanging safe data via a non-safe communication line.
With safety over EtherCAT, functional safety can be integrated within a machine. Safety logic devices, safety I/Os, safety drives can be combined with a safety protocol. And safety over EtherCAT can not only be transferred via EtherCAT, which of course is well possible, but also via other Fieldbus systems or via Ethernet, for example, for controller-controller communication in a safe way for plant-wide safety functionality. This is due to the black channel approach that we don't care about the underlying communication system. The simple integration and the simple protocol itself is loved by the customers, by the machine builders, but also by the device vendors. And we support device vendors from the ETG to integrate that in their devices. And a huge variety of different device types is available on the market.
The latest addition to the EtherCAT technology is the Master Independent Diagnosis Interface. It allows third-party diagnostic tools to work with any master implementation. The software-based interface can be implemented in master devices or diagnostic tools without any hardware changes. The demo shows three different diagnosis clients that monitor two different EtherCAT networks. Both masters have implemented the diagnosis interface. Thus, the diagnosis clients can easily access all diagnosis information. The visitor can push several buttons causing frame errors, state machine errors, or link loss errors. The diagnosis clients display this information immediately in a user-friendly way.
The diagnostic capabilities are one of the most important features in determining the success of a Fieldbus technology, and EtherCAT provides outstanding diagnostic information both at hardware and software level, enabling not only to detect errors, yet also to precisely locate them. The ETG document 1510 enhances the EtherCAT master classes specification, defining a master-independent profile to provide information to client applications like diagnostic tools or HMIs. This profile is fully based on standard EtherCAT concepts and functionalities being part already of the EtherCAT specification. Diagnostic data are presented within the master object dictionary and can be accessed via UDP IP through the mailbox gateway functionality. Through this interface, diagnostic tools will be able to gather and present diagnostic data coming from EtherCAT networks to users in a user-friendly way, independently from the specific master vendor.
EtherCAT is the dominant technology in the Fieldbus domain, and Ethernet is the standard for wired office applications using switching technology. TSN is the enabler for real-time communication in a heterogeneous environment. In some cases, a combination of these two technologies is required. 1. A better understanding of TSN and the streaming concept is a precondition for a successful implementation at the factory floor. 2. The adaptation of EtherCAT in this environment can be done very efficiently with an upgrade at the master side and no changes to the slaves, and a moderate extension in the bridges connecting EtherCAT segments. Experts from ETG are part of the IEEE working groups. So, ETG is actively shaping the evolving TSN standards. This ensures compatibility with the EtherCAT standard and a short time to market for vendors supporting the EtherCAT and TSN approach.
EtherCAT and TSN are a perfect match. The reason is that with EtherCAT, the EtherCAT master only needs to send one single frame to exchange all the process data. Now, it's easy to map this single frame to the TSN streaming concept, and only very little TSN resources are required. The concept of the mapping only requires a small software enhancement on the EtherCAT master side, but actually does not require any change on the EtherCAT slave side. EtherCAT did have the so-called open mode in the specification from the very beginning. The open mode means that an EtherCAT segment can be connected directly to a switched network. In the past, switched networks didn't allow for real-time. TSN brings this real-time now, and now such applications can be done that the EtherCAT master and the EtherCAT segment are connected via a switched network. The benefit is that now big machines, plans, can be structured in a different way. So TSN allows to connect the EtherCAT master on one side and one or several EtherCAT segments on the other side of the TSN domain. While at the same time, via only one network port on the EtherCAT master, communication is also possible with other EtherCAT master systems which are connected, or even with a line controller which controls the whole machine.